Okay, so today I'm with Bobby Faucher, and today we're talking about LRL's Extreme Search product. Bobby, can you tell me a little bit about how you discovered this product and why you think it's relevant in the DoD space today?
Sure. As I think through today's cyber problems, I really like to think about what's happening out of the National Research Labs. And that's where LRL was born out of, was Sandia Labs. And so we met through one of our great partners, Intel, and we started to have conversations around what their product is and what it can do.
Yeah, excellent. And what does it do? Tell me exactly what it does for the DoD.
So in a technical perspective, it basically turns an FPGA into an MPU and tears through data at rates that have never really been seen before. But it can really do it at a level that doesn't require a supercomputer, which are very expensive to both design, field, and use.
Okay.
And so in the aspect of the Department of Defense, who has large data sets that have expanded in ways that we could not foresee through COVID. And the government has had a difficult time being able to not only store that data, but process that data. All of the applications that the government has either purchased or developed were meant for a world in gigabytes. But now when we think about terabytes, petabytes, larger,
Right.
the systems that they have in place today, from their software to their infrastructure, to their servers, to their data, to the analytical tools, just can't keep up. And so what you find yourself in is trying to be able to go through your data to be able to make a decision, but it's taking the government 4, sometimes 7 days to reach an answer.
Right. In today's cyber world, that's too long.
Too long.
Yeah.
You have to be able to operate at minutes and seconds.
Right.
And so what they've done with their amazing technology and their product is bring the government back into its gigabyte worlds without having to...
Or terabyte world.
Or right?
Yeah.
Without having to just completely redesign their infrastructure all at once. It gives them the ability to redigest what they have.
Excellent. All right. Thank you very much.
Yeah, you're welcome.
This is the Dell PowerEdge R750 XA rack server. The XA stands for Extreme Acceleration. This is Dell's flagship server for GPU-based workloads. It can hold up to 4 double and 6 single-wide GPUs. It can even be ordered with liquid cooling. Installed in GPU slots 31 through 34 are 4 Kuona cards. It's kind of hard to say. A Kuona card is a Hitek CS200D with the LRL NPU image right on the FPGA. You can follow the link to the Hitek website in the description below. All scan workloads are running on the Kuona cards. On each Kuona card, there is room for 8 M.2 NVMe solid-state drives, but each card that I have right now is only half populated with a 4 terabyte Sabrent Rocket 4 Plus solid-state drive. Again, I'll put all the links in the description, and you'll have all the information needed. Okay, first we're going to take a look at what it would look like if we weren't using this technology of a GPU and the Extreme Search product, okay? Here's my logs, like real quick. I just want to show you a few. It's 100 files, 1.8 gigs each. You see that? Let me show you differently. 1.8 gigs each, okay? Here's what it looks like. Just web logs, all right? And then we're going to look for, in this case, we're going to look through all these web logs for a word like malware, okay? I'm going to do it the old school way that we've been doing it forever. Actually, they're not all web logs. See, there's all kinds of just basic security logs, right? Anyway, here we go. We're going to start our search. I'm just going to do a grep looking for malware like this, okay? egrep, and we're going to time it. I want to see how long it takes, okay? Go. There you have it, about 15 minutes. Now let's deep dive into Extreme Search. Here we see that I have a mounted volume called GV0. This is a Gluster mount. If you're not familiar with Gluster, it's an open source Linux util to combine a lot of different solid state drives into one mount. But what's interesting about it is that it can peanut butter spread those files across the 16 solid state drives I have. In fact, my Python script, which I'm going to be using to leverage the GPUs and the Extreme Search NPU technology, inside of that code, which I can show you now, I actually print out the distribution of the files across the various solid state drives. Okay, so let's do that. So there is, let's first, we'll take a look at my script in case you want to see it. You can see which libraries I'm using. I have to show it which cluster volume I want to talk to. This is my host name, and I'm just going through text files, and then I'm just printing my results. Okay, so we can go ahead and run this now. I'm going to start a timer. Go. Done. Okay, now what's important to note here is that we're printing not the string of data within the file, we're just showing you the file. Security62.txt has the word malware in it, okay? Now this is an important distinction. We're really not string searching in a typical grep fashion. What we're doing is we're eliminating a lot of the noise. It's important to realize that if I have 100 files and I can show you that only 13 of them have the interesting string in it, then I can feed that into Splunk, thereby making all my other technologies better by filtering out the noise early on, and I don't have to worry about passing this data through a security boundary or a CDS, which slows things down, right? So I hope you understand the power of this technology, and please reach out to myself or Bobby if you have any other questions. Thank you.